All right, now we're going to check and see how will changing one of the aspects in your equation affect the other members in your equation. So we're going to do this middle section of this worksheet where they're asking you the different stresses on the system, saying what you're going to increase or decrease. And then the stress that they're asking about is the thing that's dashed out. And then you're going to say whether or not the other aspects increase or decrease. So first of all, here is the equation that we're using to look at it. So I'm going to show it to you here when I explain the different aspects of the problem. So the first problem we're going to look at is increasing the CO2. So the question is, how will increasing the CO2 affect the equilibrium, of the factors that are in the problem? So what I want to know is, how do these factors change? By changing the CO2, how does the H2 change? How does the carbon monoxide change? How does the water change? So I can find that out by just applying my handy dandy trick of toward a decrease, which I abbreviate touchdown, T and D, toward a decrease, and away from an increase. All right, away from an increase. Those are the two ways to solve any of these equilibrium problems. So the first thing that you're going to do is you're going to look at the factor that they're telling you about, and wrong equation. It asks me the CO2, this equation. All right, so I've got this equation, which is the one here on the page, CO2 plus H2 in equilibrium produces CO plus H2O. So I've got this equation. And the question at hand is, I want to increase the CO2. So just like I explained before in the previous video on shifts, I'm going to go to the factor that they're talking about, and I'm going to write the letter either I for increase or D for decrease over top of whatever factor they're telling me is being stressed. So they're telling me I'm going to increase the CO2. Then I'm going to go to the middle of this equation, because this is where my arrow is going to be drawn every time. Don't draw it right next to it, or you're going to get confused, because this is on the same side as that guy. And so you got to go to the middle here, and the rule is you go away from an increase. So the rule is away from an increase. So I'm going to draw an arrow leading away from this I that I just said it's going to increase. Everybody that is on the right-hand side of this equation, which, by the way, are my products, are said to be favored. That means this guy is going to increase, and this guy is going to increase. And this guy is going to decrease. So I can simply fill in my chart with the necessary increase or decrease depending on the elements involved here. Everybody that's on the front end of the arrow, that the arrow is pointing to, is going to increase. This reaction is said to shift to the right in favor of the products. Being in favor of the products means the products will increase, and the reactants then will decrease. The reason being is if I add more CO2, now I have more reactants, and what will more reactants do? They'll make more products. And if I make more products, hydrogen is going to be used up in the process of making more products, specifically the water. So by increasing the CO2, it forces my reaction to make more products and therefore use up more hydrogen. That is why I just simply say this and this increase, and that guy decreases. So when you have a single factor, you put the A or the I over whatever it's telling you. This specifically said increase your CO2, and then you can solve for what effect it's going to have on the rest of the members in the equation.